Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. Let's go to that. Let's go to that. Pull requests. What do we have here? Fix and remove various invalid comments. Okay. Okay, yeah, indeed. Dustin, enable this for independent balancing. Yeah. Okay. Turned on by upgrades. Looks fast. Uh-huh. Oh. Can gain experience. Um, um, I think even if the value is low, the intent is that this is fast, not slow. Hmm. Okay, great. Heavily protected. Orbital beams should be devastating. Radiation. Mhm. 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 Okay, I think this is okay. Mhm. 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 Great. Mhm. Great. Okay. The Gatling can speed comments make no sense. Mhm. Mhm. Good. Then let's go here. So, review approved. Let's see. Mm. Clean up. Game message. Blah. Okay. Good. Then we can merge it. Good. And here about containees AI exit state if its container object dies. Okay. 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 Great. Then next, let me see if I need to follow up on any of my own changes. I think I do. I think there were still bot comments here. Okay, allow surrender functions. It's not found. Here. Mm-hmm. Right. Mm-hmm. I see. Mm. Mm. 1, 2, 3. Mm. Mm-hmm. 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 So, mm-hmm. 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 Okay. Mm. Now there's also another one here. Does this use a group? It does here. Mm. Okay. Mm. 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 Okay. Maybe we remove this comment here. Okay. So this one is solved. Mm. Right. So. Mm. Mm. Right. So there was a break here before. Yeah. Mm. Mm. Right. It's a good point. Something I did not consider. Let's search for all loops. Let's see if there's any returns inside a loop. If yes, then we need to double check that we didn't replace a break for a return by mistake. Mm. Mm. Continue. Mm. Mm-hmm. 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 There's a return. This one could be wrong. Likely is wrong. Oh, no. Yeah, it is wrong. So this one also needs to be a break. Okay. Okay, that's it. Just two. Okay. Okay, fantastic. Much appreciated. Yeah. Much appreciated. Good. The bot only saw one of them, not both. Okay, so we have that, and that. Pass that to surrender functions. Fix to wrong returns. Maybe we can also do a replicate to generals already. Let's wait a moment. Oof. Interesting. Private. So we simply take all of this here. Okay. Maybe we should move this down. Down here. Okay. Move function decal down. Replicate in generals. So, then I put a checkbox here. And that's it. Done. What is this? Okay. Improve performance by reducing packet allocations. Okay. So, okay, so the next we can probably look at this one here again. Let's see what was done. Okay. A bit of your math. Okay. Yeah. Origin wrappers. Origin still uses origin. Origin means the original EA code called bare CRT functions. SQRT equals SYNF. The suffix marks which exact CRT function was used originally. Square root origin double was square root. Origin is a really... Origin seems like a bad name choice. Name choice for this. What would be a better name? I don't know. um. Mm. 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 Origin. Mm. Yeah, it's not clear to me what better name would be. This one is also a bad name. Trick. um. Mm. 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 So Trick still exists. So. Mm. Yeah. Mm. Mm. Uh-huh. Hmm. 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 So these ones would need to be removed at some point. So maybe we call these legacy. Done legacy. Maybe. Mm. Legacy. Hmm. And then here. Oh, wait. Hold on. There's more. Ugh. Um. Mm. 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 Hmm. This is not good naming. They naming. They should just be called. Just be called SQT cos sin. Now they do conflict then with some of these here, with floor. No. No. It doesn't conflict with floor, but it conflicts with seal. So seal, then the callers to seal would need renaming to CLF. Actually, not really. Um, keep it simple and consolidate code. No confusing duplicates. Yeah, I don't agree with this origin naming. I don't agree with this trick naming. I don't agree with keeping these duplicates because these duplicates here, they block the clean name, right? That's why he put these underscore origin versions, yeah, for all of these functions, because the non-origin versions are already taken for the non-deterministic names, and now he uses this as an argument to not remove them and keep this origin suffix, which is not smart. It's not smart. So I think this needs simplification because like we need to think a step further. Like he's thinking right now about how to, fit it in and make it easy for touching. But we already need to think like one step in the future, and that is usability of these functions. Yeah. Because the next time someone looks at it, it's like, why is there an underscore trick? Why is there an underscore origin? And which one do I pick now? And then why do they have these suffixes in the first place? Whereas if we just put underscore legacy and then one variant without any suffix, just like plain math functions, then it's very clear what these things mean. Underscore legacy suffix means it's legacy and it's meant to be removed in the future. Yeah, it's just kept there for now. And then otherwise, the other ones, just regular math functions without any suffix, without any prefixes, clean and simple. Yeah, and so there's no confusion. The names are short. Everything is nice. So this is what I would like to see here. Right now, it's too complicated. The way he wants to put these names is not great. Yeah. This is identical to seal, not identical. Seal float is original EA used in rendering. Mm. Mm-hmm. Yeah. Then okay, then remove these duplicates and simply call seal or std seal and call it the non-logic critical call sites. Mm-hmm. This way, these extra functions can be removed here. EA legacy from two different sources. This is EA legacy from two different sources. A10 Arcos. Okay, let me take a look at that. WW Math. A10. Yeah. ACOS, ASIN. I see. Okay, let me take a screenshot of this. A10. Then use A10, asyn, acos, like the original. No mixed casing. Casing styles. Okay, I don't know what he's doing here. I don't understand this comment. Is he arguing for or against it? I don't understand. It clearly is inconsistent. This one says A10 with a lowercase t, and this one says acos with a lowercase with an uppercase c. So these are not consistent. Like, it's not supposed to look like this. The original said acos with lowercase c, asyn lowercase s, a10 lowercase t. So why is he then suddenly deciding to introduce an uppercase c for acos? It makes no sense. Like, there's no rationale behind this. And then he puts here some stuff. It becomes acos trick. No conflict. Overloads are dangerous here. Origin versus f origin separates math path, not just types. Math path. Acos origin double. Original called acos. CRT double. Overloads are dangerous here. How? Separates math paths, not just types. Overloads, the compiler silently picks the version by argument type. Yeah, which is the intent. I mean, it's C++. That's the way it works. I think the reason why these exist is because C doesn't have function overloading. C function overloading. There's all this text here, but it doesn't say whether it supports function overloading. Function overloading is not a built-in feature. It can be achieved through a technique called name mangling. But this is this is C++ code base, not C code base. The reason f suffix math functions exists is C. It's for C. I do not agree with your arguments. For dangerous overloads. Overloading is very common in C++, and is desired to call the right function by the right type, the right function for the right type. Floats f get value, say auto f2 acos f1 function overloads picks function overloads picks the right version. For any of the supported float type. C does not support function overloading. Programmer does not need to remember to call f version for floats. Compiler CMake. Okay. doesn't. Yes, the exclusion is necessary. VZ6 doesn't support SCD and long. But see, it probably creates like a library that is then compiled. Built with fair. Okay. Okay, I guess that's fair then. Yeah. SQRT double is a free function. Free function from trig. But it calls it does call double version. But there's also a float version here. Why does it claim here it calls double? And yeah, so what does it mean? One definition rule violations. One definition rule. Okay, whatever. Mhm. Um, what is the point of moving? Let me go to www math again. Mm. Use legacy suffix. I don't know. I mean, okay, let me delete this comment here. And then let's add a comment to trick. What is the point of moving the function body to www.math when it is just meant to be called through this trick file? Just do it here. But keep it simple and just do it in here. Mm-hmm. No trampoline to www math. Mm-hmm. Okay. So I think that covers the review. Mm. Mhm. Okay. Good. Then that is sorted. Then let me take a look at this here again. It's still failing to compile. Oh, right. Okay, that's fair. Allow surrender method declarations are missing. Define. Do we need the braces per case? It makes the function a lot longer. Let me see. Game logic, dispatch. Where is it? Here. Well, we could remove it. Yeah. The problem then only is like if you add like a variable declaration in here, then these are needed. But okay, you're not supposed to do that. Yeah. Yeah, I guess you can remove it. So do it like that, yeah. And what we could also do is write it like so. That would be super compact. Yeah. I mean, why not? Mm-hmm. Mm-hmm. Boom, 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 boom. Oops, that was a bit too much. Oh no, it is supposed to be like that. Really? Yeah. Okay. Empty. Mm-hmm. Mm-hmm. I don't know if that really increases readability. I don't like it. Mm. Mm. I don't know, I wouldn't change it. Yeah, it's super compact and dense, but I don't think it's worth it. Mm. Okay, it's still failing to compile. Okay, so we did fix this, but there are more complaints here. Let's see what's up. Okay. 954. Ah. I see. I see. Okay, I didn't consider that. So this one actually needs to go here. Mm-hmm. Mm-hmm. 1129. Okay. Fair enough. Okay, is that it? How about we move it below the comments? Okay, that should fix it. Fix compiler error. Okay. It's not strictly necessary. Braces only needed if a variable needs declaration in switch case label. Scope. Do you want it removed? Okay. Good. Then I think I will be done here with this for now. Let's go back to our particle stuff, which we had paused for a while now. Yeah. So what's the time? 1:20. Yeah. Okay, so yeah, particle is this. Okay, so we still had troubles here with the particle system. Yeah. The particle update, it still doesn't look quite right. Probably because of the damping. Yeah. which we try to modify here with this time scale, which I have already forgotten. Even though there's a comment, I don't remember why this was correct. So there was 1 times plus strength 0.7 times so this strength can also go above 1. Let's say time scale. Depth. So if the time scale is 1, then this becomes 0, and this whole thing becomes this whole thing becomes 0. Then this becomes 0. What? Okay, let me debug this real quick. I'm a bit confused right now. To me, it looks like this becomes 0. Huh? I would have expected this should be 1. Maybe I'm missing something here right now. So is he happy now? The bot is happy. Yeah. Mechanical extraction. Okay, before we launch debug session, let's first launch the original here. Okay, takes forever to load. Great. Hmm. Hmm. Looks like Baptista is preparing a massive refactor here. His BGFX branch looks pretty massive. Has been going on for a while now. Just one-shotting a massive implementation. Yeah. Until he runs out of tokens. Hmm. So, then we wanted to load the damping test. So, let me put a breakpoint here. So timescale is 1, and the damp exp is also 1 time. Well, how does that work? Ah, so right. So it's 0 times strength. I somehow read it as like 1.0 plus 0.7 and then times is yeah. Okay, so that makes sense. Yeah. Okay. So so I would say this cloud gets much larger, right? It looks similar, but it's not quite the same. Yeah. So, So let's say remove the dampening again to 0.5. Okay, so right now it looks pretty much identical as expected. Okay, now it already looks different. It moves too fast. And the size is too small. It's too small, but it moves too fast. How is that possible? Fill damping. Okay, let me take this function. Let's clean up here a little bit. Okay. Let's open ChatGPT. Let's chat a bit because I don't know what I can do here. I did have a chat for exactly this some time ago. But let's just make a new chat. Given I have the following two functions. Was newly was newly added, and render update was previously a fixed time step. Fixed time step update function, which was attempted, which was decoupled from the fixed updates to from the fixed updates where timescale is the ratio between the render updates. So ratio, let's say logic time divided by render time, I think. Is that right? I think so. Draw. Yeah. Following we have two C++ functions. Calc timescale was newly added, and run update was previously a fixed time step function, which was decoupled from the fixed update, where timescale is a ratio. The dampening the dampening calculations are a problem. They are not exact. How can we improve this to look like the original fixed time step updates? Let's see. Fundamentally approximating the wrong thing. The original fixed time step behavior was probably something like, yes, performed once per fixed simulation tick. When you move to variable time step rendering, you correctly change it to that. That is already the mathematically correct continuous time equivalent. Yes. The extra compensation is actually introducing error. Is it? Oh. Y is already correct. Suppose the original fixed update was that. Where per tick, dt fixed. Okay, let me test that. But we did test it on strength 0, and it also didn't look correct. So I don't think that assessment is correct. But let me test that again, yeah, just to make sure. So if we have strength 0, then this will always return 1, right? So yeah, so let's test that. The issue is usually one of these semi-implicit Euler ordering differences. Your update order is velocity. This is not equivalent to subdividing into multiple smaller fixed steps unless damping is handled analytically. At small dt, error is tiny. At large dt, error becomes visible. Okay, I don't know. I already can't follow. Yeah, okay, yeah, whatever. Probably what you're noticing. Exact fixed time step equivalent. V plus equal. Use the analytic damped integration. First convert damping to decay constant. What? Then decay. Then exact integration. This exactly matches infinitely subdivided fixed time steps. Recommended implementation. Instead of that, do... Oh boy. Near node damping. Okay. Okay. Well, let's try it. I don't have a better suggestion. So looks very complicated though. So what's the difference here? Oof. Well, decay. Decay. Okay. Yeah, okay, whatever. Okay. Okay, so that's for acceleration for this one. Okay, and what about the other ones? Okay, then let's just copy pasta this. I can't say that I understand it, but maybe we don't need to. Okay, then we remove all of this. So we have K. Mm-hmm. Mm. Mm-hmm. 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 Okay, let's say here damp exp is time scale. Mm-hmm. Okay. Okay, blah blah. Well, okay. Okay, then we remove this here. Mm. Mm-hmm. 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 Okay. Okay. Okay, let's test it. If this works, then I have to admit that ChatGPT is a math genius. No. Mm-hmm. Uh-huh. Mm-hmm. Okay. Well, it already looks different, doesn't it? Yeah, it looks different already. Let me put a breakpoint here. So, well, that's not right. Well, damping. Okay. Mm-hmm. Hmm. Hmm. Well, that doesn't work. Let's look if it at least looks the same when we. Hmm. No, it looks different. Hmm. Hmm. Well, damping. Hmm. 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 Okay, let me suggest the following. Okay, rewrite the functions. Rewrite the functions so that it will look stable, that it will look consistent at any frame rate. Render frame rate. Let's confirm first. Okay. Do it. Compute decay. Okay, let's just copy the whole thing. Yeah. And test it. Let's do a elif 0 if 1 and if. Yeah. So show me what you can do. So where's compute decay used? Here, angular decay. Okay. Okay, then let's test that. Yeah. If that still doesn't work correctly, then let's give it the original function. Maybe it needs more information. Whoa. Well, that already looks suspicious. Yeah. Let's see if it at least is stable. It looks stable. Yeah, no matter how fast the FPS is. It looks deterministic, so that's good. But it somehow is too fast. The velocity is too fast. Damping. Okay, where's the damping? Looks like he erased the velocity damping. No, it's here. Okay, let me say it looks to be consistent. It looks to be consistent looking across across different time scales, but the velocity is too fast. It's as if it's not damping. It looks as if it is not damping. Keep the Euler per tick damping. Show me. Is it really that simple? Pretty sure we tested that back in the day. Okay, let's test that. I have my doubts. Because it looks very similar to what we had here already before, which is that and that. Yeah, so basically the only thing it now did is remove this damp scale function. That's it. But I'm pretty sure that's not enough. Let's test it. Okay, so this looks correct, I think. Yeah. Okay, so this is correct, but now let's speed it up. Yeah, okay, but now we see there's spacing added. Yeah, so this is not correct. This looks fine at time scale 1, but the velocity becomes too large and time scale is less than 1. Let's say velocity grows Mm-hmm. Yeah. Mm-hmm. This looks correct at timescale 1, but the velocity grows when timescale is less than 1. That reveals the real issue. Fixed update was not being called once per render frame. It was probably logic update at fixed time step, yes. Render interpolation between logic states. No. Now you're doing actual simulation at render frequency. Yeah. That changes the effective acceleration to damping ratio. Because acceleration scales linearly with time step, but damping scales exponentially. Acceleration scales linearly with time step. Yeah. At smaller time steps, acceleration loses less energy. Okay, I think I understand what he means here. So this thing, but okay. So it claims that there's some. Yeah, I can't explain it myself. But it looks like it makes sense that, yeah, maybe this. Because this one now dampens the acceleration more often, right? Yeah. You must scale acceleration using the same damping integration. Okay, copy paste this bullshit here. And then we take this. Okay, then let's check that. Preserve original artist tuning. True discrete time frame rate independent conversion. Okay. Let me see that claim. If it doesn't work, then I think it's time to hand out some bitch slaps here to the AI. No. It seems like everyone is using AI with very large success rates. Yeah, but whenever I go to the AI with my problems, it suggests all sorts of bullshit, but rarely a straight answer and solution to my problem. Yeah. You always need to prompt it 10 times to get maybe something remotely useful, but then it all falls apart because, oh, I loaded the wrong thing. Because, because it did not figure it out. Yeah. It's still a problem. Now we have the inverse problem. No. Oh, man. I really don't understand the hype of the AI because the AI is clearly broken. Yeah. It's clearly broken. How do we describe this now? So basically, okay, we can now say the velocity now looks consistent across different timescales, but now it looks consistent across different timescales, but it is too large and there is no damping at all, right? Yeah, there's no damping. Okay, let's see if it can figure it out. The issue is the acceleration scaling formula I gave assumed acceleration was applied before damping in a subdivided step. But the original update order, man, just give me the correct solution. Let's see what's coming up with now. Okay, what do we have here? Oh, okay, let's replace this. Yeah. And this. Okay. So this better. I don't know why it keeps renaming those functions. I put this here. Mm-hmm. 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 Okay, let's test that. My hopes are not high. I would expect if the AI truly understands the problem that it can generate the solution straight away, but like seeing that it just like generates try after try and try something new. Yeah, basically I'm the QA tester of the AI now. Yeah, to test whatever it suggests, but I think it doesn't fundamentally understand the problem. Yeah, it just spits out things that it predicts that this could solve my problem, but it doesn't actually know. It just predicts that, yeah, this seems to be the most likely thing that you can try that may work. Yeah, which so far hasn't been the solution. Okay, but we are hopeful. What do we have now? Okay, so this looks good. Yeah, so this I think is fair to say. Then, oh, this looks promising. Oh, after all, the AI figured it out. Oh, wow. It just took many prompts. Okay, but this looks very good now. Okay, cool. Let's look very closely. Yeah. Yeah, it looks very good. Yeah. Yeah. Okay, wow, I'm impressed now. I take everything back I said earlier about the AI, that it's useless or whatever I said. It actually figured it out. What does it do now? Damping, that, timescale, decay. Okay. 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 Then let's remove this bullshit here. Mm. Mm-hmm. 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 Okay, cool. Mm-hmm. Now the question though is we should probably, yeah, we should probably put it back into this one here below. Mm-hmm. Mm-hmm. Okay, scale down, Excel factor. Time steps. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Mm-hmm. Good, then we delete this bullshit here again. Mm-hmm. And we copy pasta this here. Mm-hmm. Mm-hmm. Okay. Okay, fantastic. Okay, then we can remove this here. Okay. We do that and that. Okay, so is this correct now? Size decay. Yeah. Decay. Okay. Angular decay. Let's rename this to scale damping. Okay. Then let's check that it still works correctly. Okay. If they have no risk, I can only tell after I've seen them. Maybe it's okay. So let's check it again if it's still correct. Okay, that looks very good. I like it. I like it. Very good. Yeah, looks identical now. Yeah, very good. Very good. Cool. Now let's compare a bit more complex particles. Okay, I can already see some discrepancies here. Now it looks fine. Yeah. Okay, so here it looks fine, but it looked wrong when the logic was faster. Why did it look wrong for a moment? What was that? Let me load it again. Now it looks correct. Okay, that's weird. Why did it look wrong for a moment? Now it looks good. Okay, that was weird. So we had like so, and then we loaded it. Yeah, no, it's wrong again. Oh. Okay, that's weird. So there's some other issue here. Mm. Okay, there's still some issue here. But right now I cannot tell what the reason for this would be. Let me see the time scale. It should be 1. It's not. Huh. Because we don't have a frame limit, so... Huh. Time scale. Go to draw. 30. Sorry. Okay, to me it looks like there's some other fundamental issue here. Yeah. But it's unrelated to particles. But I also don't understand it right now. So so what we're seeing is the I don't understand this. This should return 1 here, this function. True. Okay, anyway, I'm pretty happy that we fixed the other issue. Yeah, let's ignore this for now. Let's maybe check it next session. Yeah, there's some other issue we need to look into. Okay, but other than this, it looks very good now. Yeah. This looks really good. Let's look at the fires here. Looks good, yeah. Okay, this is really nice. Okay, let's take a look at the slow motion. Slow motion particles. So beautiful. Look at this. Wow. Amazing. So pretty. So smooth. Except for the shell. The shell looks funny. Whee. Okay, cool. Okay, I like it. Looks very, very promising. Now there's still more work to do. Plus we have this one bug. Let's continue that next session. So there's something weird is going on here. Yeah. But I'm pretty sure it's a particle unrelated issue. It's an issue with our frame pacer or engine update. Yeah. Okay, but that's fine. Okay. Good. Then has been 2 hours 30 minutes. I'm very happy that we made some progress. The next session, let's investigate this issue here. Yeah. And then hopefully one day we can enjoy fully smooth particles. Now there is still a issue here with, as you can see, there's like clipping, right? We can also see it here on the Dragon Tank. Like they don't gracefully fade out, but I think that's a data issue where the particle despawns before it actually fades to zero opacity. But it's just the way the particle is set up. So we could overwrite this behavior from code, but that's a separate concern, right? Because it's already a problem in the original with the original look, right? So we just have to accept that for now. Yeah. So particles are supposed to fade out gracefully, like this one here, like this big one here. You see it fades out very nicely. But here, these flames, they just despawn before fading. Same here. It's very obvious. They just like disappear here. Yeah. Which is very obvious at slow motion, right? But it's not so obvious when it's faster. Yeah. Okay, cool. Then that's it. Okay, then I will end it here. I wish you a great day or night. Until next time. Goodbye.